Hello and welcome to this video on installing your virtual GPU software on VMware. This video covers the process if you bought the software as a standalone bundle or if you're using it as part of the NVIDIA AI Enterprise product suite. The installation process for both is actually identical. So first, let's take a look at the overall architecture of vGPU and the components we'll be covering. At the bottom of this picture, you'll see the server hardware and the physical GPU or GPUs. On top of this, we have the hypervisor, which in turn runs the virtual machines with our users' applications. This video concentrates on installing the hypervisor GPU manager drivers and the NVIDIA guest drivers for the virtual machines. We'll cover both Windows and Linux installations. The third step is to install your licensing service and configure your VM driver to talk to it. You can use our cloud-based licensing service or CLS, or our on-premise delegated licensing service or DLS. There is a separate video that covers the installation of the license server, so I've put a link to it at the top of the screen now. So the first thing we need to do is download the software from our licensing portal. If you bought the product, you'll have access to this portal. If you haven't bought the product, I've put a link in the description below so that you can get an evaluation of either Virtual GPU Standalone or NVIDIA AI Enterprise. If we go across to the download software section, first thing we're going to need to do is just verify which product we're going to be downloading. So we can choose vGPU here. In this particular case today, I'm going to be installing the drivers for NVIDIA AI Enterprise, which are pretty much exactly the same as the vGPU drivers at this point. Next thing we're going to do is choose the platform, say which platform we're on. In this case, it's VMware vSphere. And we'll go to the platform version. In our case, I have ESXi version 8, so we'll choose that. Now you'll see various packages listed here. We're going to go with the latest one that's available, so the version 5.1 of this, and we're going to download the bundle, which is going to include the drivers for the hypervisor and for the virtual machine guests. So if you don't see the current version of vGPU or NVIDIA AI Enterprise listed here, it could be that your support subscription has actually elapsed, and that's why you're not seeing the latest version of the software. Once we've downloaded the software, we can move forward and install it. So let's take that file we downloaded and extract the contents of it onto our local workstation. Files we're going to be working with today are the guest drivers for Linux and Windows, which are part of this download. We're also going to be going into the host drivers and downloading these zip files here. Next thing we need to do is copy these zip files down to our VMware server. So in order to do this, I've just started up a WinSCP session to the server here. And you can see here's the directory that I just unzipped those host drivers into. So we just need to put this now onto the VMware server so that we can access it and run commands from the command line. In this case, I'm going to go to VMFS. I'm going to choose volumes, SSD2, and I've created a directory here called VIBs, which I've used previously. As you can see, the previous version of NVIDIA AI Enterprise was installed on this server originally, so that's why I've got those files there. So next thing I need to do is just go in here and copy those files. As you can see, they're slightly different. These were version 535 of the driver. These ones are version 550, so a later version. Just drag and copy them down there, and we'll be ready for the next section of this install video. Before you even boot your hypervisor, I'd recommend having a little check in your BIOS. There are 3 settings that are going to trip you up during the install if you don't have them set correctly. Firstly, make sure support for virtualization is turned on. With Intel CPUs, there's a setting called VTD, and with AMD, it's referred to as IOMMU. Secondly, there's a above 4 GB decoding setting that needs to be enabled. This might have a few different names depending on the hardware vendor, but essentially it's the same thing. Lastly, if you have a GPU which is Ampere generation or higher, you're going to want to make sure SR-IOV is enabled in the BIOS. Again, what it's called and where it's enabled will vary based on the server manufacturer. Without these settings, you might actually get as far as adding GPU profiles to your VMs, but at some point you will get a hard error, so it's best to check these settings before setting out. After this, we can boot our hypervisor and continue. So let's take a look at the first step, installing our VMware installation bundles, or VIBs as they're known. The simplest way to do this is to do this from the VMware server command line. It's a great way of doing it for small installations or maybe for a proof of concept. You can also import the hypervisor driver zip files directly into VMware's Lifecycle Manager tools, and you can manage your VIBs at a cluster level, as you can see from the screens that I'm showing now. But this isn't really within the scope of this video, so we're just going to stick to the command line and the quickest way of installing the drivers. So the first thing we need to do is to put the server into maintenance mode to allow us to do some maintenance to it. After we've done that, let's just have a quick look just to see if the drivers are installed on here already. So we'll type NVIDIA SMI. As you can see here, we're getting nothing back from this. We can also look using the ESXi command to actually see if the NVIDIA drivers are installed. Software VIB list, and we're just going to grep for NV, so any instances of NV, and this should actually return no entries as well, as you can see. So we have an installed vGPU. This is a completely clean system. So we've actually got two VIBs to install on the server here, and we're going to go ahead and install the first one. This is the command to install the VIB. Let's actually just tap on here and see what we've got available. As you can see here, we've got our previous version of NVIDIA AI Enterprise VIBs on here. We actually want this one, the 550 branch. So let's go ahead and install that. Okay, 550.zip, and press the enter key, and this will install the main VIB. This needs to be done before we install the vendor daemon system. Okay, so now that the installation of the main GPU manager has completed, what we're going to do is run this command again, except for this time we're going to install the management daemon. Again, choose version 550 and hit enter. Okay, so now that the main GPU manager and manager daemon have been installed, all we need to do now is reboot this server. So now that we've rebooted the server, let's just run a few commands just to verify the installation. LSPCI will let us know that the GPUs are being recognised on the PCI bus. As you can see here, there's two GPUs listed, an L4 and an L40. What you're actually seeing here are the SRIOV virtual functions, but essentially we have two GPUs in this machine. All that's looking good. Let's have a quick look and just see that the VIBs install correctly using this command here and grepping for the string of NV. As you can see here, NVIDIA AI Enterprise, the main GPU manager, is loaded. Also the management daemon is loaded too. Another useful command to type to verify that vGPU manager is loaded is the following one here. As you can see, there's a single entry, so this is looking good as well. We can also actually check some diagnostics messages here and see if there were any errors during the initialization of the GPU. So you can see some entries here. None of this looks particularly concerning. We can also type this command here, which will let us know that the management daemon is running successfully. As you can see, it is running. And of course, you can always go ahead and run the NVIDIA SMI command in here and actually just see what GPUs are listed. As you can see, we have an L4 and an L40 in this machine. Normally, you'd probably see exactly the same GPUs listed in here if you had two GPUs. You wouldn't have different GPUs in the same server, so you'd have all L40s or all L4s, purely because that's the way that our vendors certify their systems. But as this is a lab system, I've actually got an L4 and an L40 running alongside each other in the same machine. So all that remains for us to do now really is to take the system out of maintenance mode so we can progress forward to configuring some options in vCenter. So while we're on the topic of hypervisor drivers, let's just show you how to upgrade the software from a previous version of Virtual GPU or NVIDIA AI Enterprise, or remove your NVIDIA drivers completely. So if we go to a different server now and we type NVIDIA SMI, we'll notice this server has got NVIDIA AI Enterprise version 535 driver running on it. So we do have an update command, so put the server into maintenance mode and click on ESXi software VIB update, and you can actually do an update more often than not using this method. But as you can see here, we've actually received an issue because the drive is still loaded. Okay, so there are some issues around this. So actually the easiest way of doing this is actually to remove the older VIBs before we install the newer VIBs. So let me just show you how you do that. So the first thing we do is we look for the VIBs that are installed on here and what their names are. As you can see, the GPU manager and management daemon are running there. So the next thing we do is we type in the command ESXi software vib remove -n, and then we're just going to cut and paste these names into here and press enter. Just to point out, you need to do the management daemon first. You need to remove that first. Okay. So once that's done, we're just going to go ahead and repeat the process, this time for the main virtual GPU manager. Okay, and that's done. We've now removed the VIBs. Now we just need to reboot the server so that we can continue with the installation as before. So once again, just double check to make sure that the maintenance mode is on this server, and we can go ahead and do exactly the same thing again as we did before. Now, first of all, let's just double check to make sure the VIBs aren't loaded. As you can see now, it's returning 0 results from here. So we can just go ahead and install our 550 drivers, the same as we did earlier on in this video. And once again, install the management daemon as well into this server. And effectively, we get exactly the same thing. Except for we've removed the older drivers first rather than upgrading them in place. Hit reboot at the end and we're good to go. So now I've shown you how to install GPU Manager on the server from scratch and how to upgrade an existing version. After we're happy that the GPU Manager is installed, there are a few things you need to do from within vCenter. First of all, go to the host, click on Configure, and go down to the graphics section here. This will show you the GPUs that the server can actually see, and we'll also notice that they're in shared direct mode. So there are two modes, shared direct and just shared. We need to make sure that for vGPU we're using shared direct. You might actually have them listed as shared if you're doing GPU pass-through, or if you're using the older unsupported VSGA settings within vSphere. As you can see, this is looking perfectly normal. If we want to change the mode, we can go to host graphics here and click here and say shared or shared direct. We also have a basic algorithm here to decide whether we fill up GPUs first before moving on to the next GPU when we're loading profiles, or if we want to spread VMs across GPUs to actually give the best performance. So now that we know that shared direct is set, all we need to do is go and enable a quick setting just to make sure that we can do live migration of GPU enabled VMs between different hosts. So to do that, we go right up the top of the vCenter tree here and go to Configure and Advanced Settings. Then let's just go ahead and edit these settings. Do a quick filter on vGPU. As you can see, there's one setting related to vGPU hot migrate enabled. And in this particular case, it's not enabled yet. So let's go ahead and tick that box and hit save. What we can now do is we can live migrate GPU enabled virtual machines between hosts to save on uptime. Now I just want to note at this point that we're using vCenter for all our operations to do with virtual GPU. Just to point out that in order to use virtual GPU or NVIDIA AI Enterprise technology, you're going to need to be on vSphere Foundation Edition, or as it used to be called, Enterprise Plus. VMware doesn't support vGPU on lower editions of vSphere. So the next step now is to show you how to assign vGPU profiles to your virtual machines. So let's go ahead and look at a virtual machine here and actually add a profile. So if I go to this Ubuntu VM, for instance, right click on it, hit Edit Settings, you'll see here we don't have any GPUs listed as yet. If we go to Add Device and choose PCI device, it'll now list all of the profiles that are available on the GPUs that are listed on this server. Now you'll see there's loads and loads of different profiles here, and they have different numbers and different queues. Some are Q profiles, some are B profiles. What does all this stuff mean? So the first part of the profile is the name of the GPU. The number is the amount of GPU frame buffer that will be allocated exclusively to the virtual machine. And the letter at the end is the type of license. A is for virtual apps or RDSH based server desktops. B is for our business profile for office workers, i.e. our virtual PC licensing. And Q is for graphics professionals that use RTX Virtual Workstation or Quadro Virtual Data Center Workstation as it used to be known. If you're installing NVIDIA AI Enterprise, you'll also notice we have C profiles, which you'll probably be using exclusively for compute or AI workloads. Also worth noting is that if you're running mixed workloads, so maybe VDI workloads during the day and compute workloads at night on the same hosts, what you would need to do is install the NVIDIA AI Enterprise VIBs into your server, because the vGPU standalone product VIBs don't come with compute profiles. So once you've selected your GPU profile, in this case I'm going to give it an L4048C profile, which is effectively the whole GPU because the GPU only has 48 gig of RAM, then we can boot our virtual machine up and install the drivers as necessary. Now, if your VMs don't boot after you've given them a GPU profile, one thing I'll just point out are there are some settings that you may need to set here under advanced parameters in terms of PCI pass-through parameters. What I'll do is I'll put details of that in the description below. So if you have virtual machines that have large memory or you have GPUs that have large memory, just bear in mind there might be a few parameters you need to enter in here. In this particular case, I'm just going to go ahead and start this virtual machine. So now we're going to install the drivers into our guest virtual machines. Remember to install the drivers from the same virtual GPU or NVIDIA AI Enterprise branch as you installed the hypervisor drivers from earlier. During upgrades, we do support the guest drivers from either the previous branch or the previous long-term service branch, but it's always best to be on a matched pair of hypervisor and guest drivers. So first, let's take a look at the Windows operating system. So what have I done to this VM? Well, I've installed Windows 10 into it, I've installed the hypervisor drivers, and I've had to enable RDP on here so I can get access to the console. Now, normally when you plug in a virtual GPU, most hypervisors, you will lose connectivity to the console when you do that. So all I've done is just enabled RDP in here just to give me a way of coming in here and doing some management after I've plugged a GPU in. Now what I've done is install Windows Update. I've downloaded the virtual GPU driver from the same driver package that we used to install the hypervisor. And I've also copied the client configuration token down into here. Now this client configuration token is generated by the licensing service in NVIDIA Virtual GPU. So as I mentioned earlier on, this isn't part of the install in this particular video, but I have linked a recording to how to install a license server in the description of this video should you need that. So another thing to point out is as we're using virtual GPU and virtual GPU profiles, you need to use this virtual GPU driver within your virtual machines. What we don't support is the driver that comes for free from our website. So if you go to nvidia.com/drivers, you'll see there's a whole bunch of drivers there. You might actually even see that the driver for your GPU exists. Well, that driver isn't going to work within a virtual GPU environment. We need to have the one that comes as part of the overall package of virtual GPU. So to kick off, let's just double click on the driver installation, open the package up, and start the installation process off. Okay, and yeah, we've got a couple of options in here. There's Express recommended. If we've got a previous version of the driver and we want to uninstall that at the same time, we can come in here and say perform a clean install, where it will uninstall the older driver. But in this particular case, we're just going to go in here and just select the Express recommended installation. This is going to take a couple of minutes now. But when the installation is finished, we just need to close down the driver install and just reboot our virtual machine. So now that the virtual machine's booted, let's just check to see whether it's picked up the GPU successfully. So if we go into Device Manager, we'll actually notice under display adapters that we now have an L40 8Q profile listed in here. That's L40 is the GPU, 8 is the amount of gigabytes the frame buffer is, and Q is the virtual workstation profile that we've got in here. Also, if you right click on the desktop and go to the NVIDIA control panel, what you'll see in here after agreeing to the terms for the first time is that the driver is listed in here. We can also go to manage license, and you'll see at the moment it's actually telling us this system does not have a valid RTX virtual workstation license. Please configure your client configuration token. So let's just go ahead and do that and restart the service, and you can see how that license gets picked up. So we've got our client configuration token. As I mentioned, I copied this down from our license server earlier on. We're just going to copy that file and put it into the correct directory on our local hard drive. That directory is under Program Files, NVIDIA Corporation, vGPU Licensing, and Client Configuration Token. Okay, we're just going to drop it in there. Now, one thing to point out is that you can actually put a client configuration token onto a file share on the network as well, if you want to manage it centrally, and you can, via a registry setting, point each of your clients to that single client configuration token. Check out the documentation if you want to find out how to do that. Now all we need to do is we need to restart the NVIDIA service on this virtual machine, and you'll see that license gets picked up. So let's go to the NVIDIA display container LS and just restart that service. You'll see the control panel disappeared for a second there. And in a few seconds time, what it'll do is it'll go out to that license server, get a license. You can see it's acquiring the NVIDIA license. And after a few seconds, it'll come back and it'll say that that license has been acquired. There we go. If we go back into the control panel again, we'll actually see the IP address of our license server there and a message saying that your system is licensed. Now, if you don't license your virtual machine, the virtual machine will get full performance for the first 20 minutes after it's booted, not after the user logs in, after the VM is booted, okay? After 20 minutes, it'll actually reduce to 15 frames per second performance, okay? And we'll start to throttle down compute performance within the virtual machine. When that virtual machine gets to 24 hours without a license, it'll actually go into full lockdown mode, so there won't be any CUDA or compute performance at all within the virtual machine, and will reduce the frame rate down to 3 frames a second, so that's unusable. So what I'd always recommend is that you have a license server and you have your licenses checked out in order to get full performance from within these virtual machines. So one other thing to point out, you can go in here very simply and have a look and see what's been going on with your licensing. If you go into this directory here, C:\users public documents, NVIDIA logging, you'll actually see the log file for vGPU. As you can see here, NLS initialized, the license was acquired successfully from here. So this is a good example of what should be happening here. If you see any errors in here, then you probably need to look at troubleshooting it. One of the most common issues I see with the client configuration token is that the time isn't in sync with the time on your license server. Okay, that's one thing I see. If your virtual machine is 5 minutes either way adrift from your license server, then that token won't actually authenticate you to the license server. Okay, so always check your time as the first instance. Probably look at things like firewall as well. You need to have access through to port 443 and occasionally to port 80 as well, between your virtual machine and the licensing service. But as we can see here, we're all good to go, and we now have a running Windows workstation running at full performance with virtual GPU. Okay, so let's show you how to install the virtual GPU driver into a Linux VM. So this virtual machine is a standard Ubuntu VM, and I'm just going to hit the lspci command just to see if the GPU profile that I entered earlier has been picked up by the Ubuntu operating system. As you can see there, it has been. So this is a standard Ubuntu VM here. All I've done is run updates on it. I also took the liberty of installing OpenSSH on it as well, so I could get access here via PuTTY. Now, If you install a vGPU profile into a Linux VM and you don't install a driver, what will happen is it will install the NVAIE driver for you. Now this is an open source version of the NVIDIA driver which we need to disable before we can continue with the virtual GPU driver installation. So let's just have a quick look and see if that NVAIE driver is loaded. As you can see, it is. So what we're going to do now is we're going to blacklist that driver and reboot our virtual machine. So let's go ahead using our text editor of choice, and in this case we're going to use Nano, and we're just going to create a file called blacklist-nouveau.conf. Okay, I've entered the sudo command there at the start just so that we can modify this and have administrator rights. So the next thing that we need to do is put a couple of lines into this file, paste them in as such. So blacklist nouveau and options nouveau mode set equals 0. Okay, press Ctrl and O to write that file out and X to exit. And now just reboot the virtual machine so we can continue with the driver install. Of course, I need to have admin rights to do that. Okay, so now the virtual machine is rebooted. Let's just go ahead and have a look for the NVAIE driver. As you can see, it's now returning nothing, which means we're good. The driver is no longer loaded and we can continue with our installation. Now, a couple of things I'm going to do in here first. I'm just going to give myself elevated admin privileges here, first of all, so that we can install the driver without any problems. Now, the next thing I need to do is I need to copy the driver onto this virtual machine. So what I've done is I've connected to the virtual machine using WinSCP, and you can see here I've got access to my home directory within here. So all I'm going to need to do is copy the files for the installation into here and also the client configuration token so that we can have the license. So let's go ahead and drag and drop the client configuration token into my home directory. Now let's go and have a look at that zip file that we downloaded earlier. Go into the guest drivers, and as you can see here, there's a couple of Linux drivers available. For Ubuntu, we need to use the .deb package within here. So let's just just click on that and drag and drop that into the Linux VM. Okay, now that's done, we can go back in here. If we do a quick listing of this directory, we'll actually see there's our driver and there's our client configuration token within here. Now, before I install the driver, I'm just going to do a quick apt-get update to make sure that we've got all of the latest packages within this Ubuntu operating system. As you can see, we have, so I'm going to go ahead and install the software. To do this, I'm going to use apt-get install, and now I'm going to find my driver. As you can see, it's the NVIDIA Linux Grid 550 driver. Just hit enter and this will install the driver for us. It's going to ask us a few questions during the installation. This is going to take a couple of minutes to install. So after a few minutes, you may get this message appearing during your driver install. This is if you have Secure Boot enabled within your virtual machine. You won't see this message if you don't have Secure Boot, but essentially what this is going to ask us to do now is create a password to be used with Secure Boot. So it's going to allow us to create a machine owner key or a mock key so that we can allow this virtual machine to participate in Secure Boot security. Let's go ahead and create this password now. Okay, and it's going to ask us on the first time we reboot this workstation next to enter that password. Okay, so all we need to do is reboot this VM now and enter in that machine owner key. Now, you might need to use your hypervisor console to do this because the first time it boots up, you won't be able to get network access until you get past this point. So I'm going to enroll my machine owner key. Continue. Do I want to enroll the key? Yes. And enter that password that we used earlier, or we created earlier. Okay, and hit reboot. So now that we've restarted the virtual machine, let's have a look and see if the NVIDIA GPU has been picked up. NVIDIA SMI will list the GPUs that this virtual machine knows about, and as you can see there, it's picked up our L4048C profile that we allocated to this virtual machine. We'll also see that the driver version 550 is consistent with the driver versions that we installed onto our hypervisor. Now, if we type NVIDIA SMI-Q and then we pipe that to more, just so that we can see one screen of this information at a time, what we'll see here is that we're currently in an unlicensed state. So it's reporting that we have NVIDIA Virtual Compute Server, so NVIDIA AI Enterprise essentially, but it's saying license status unlicensed. So let's go ahead and rectify that. So before we go any further, I just want to point out there is a file in the etc NVIDIA directory called gridd.conf. You might be familiar with this file if you're moving from an older version of vGPU, but really you should only need to modify this file if you're doing GPU pass-through, so direct pass-through from the hypervisor, as opposed to virtual GPU. But let's just take a little look inside this file. So as you can see here, there are a number of parameters you can specify in this file. Most of them are related to our old legacy license server, but there is one here called feature type, which is set if you're using pass-through GPU here. Now, if you're using standard virtual GPU, then the driver will look at which profile you allocated to the virtual machine and it will allocate the appropriate license. However, if you're doing GPU pass-through, we can't do that. So you might need to set the feature type to the license that you want it to check out. Now, by default, if you're using Virtual Workstation, you will specify type 2 here. If you're using NVIDIA AI Enterprise, then you'll want to specify type 4. It's actually listed as Virtual Compute Server, which was the previous name for NVIDIA AI Enterprise vGPU beforehand. So just move the feature type parameter to whichever one you want to use, and then literally just click Ctrl-O, Ctrl-X, and you'll be good to go. As I say, you shouldn't have to do this with virtual GPU, as the correct license should be discovered automatically. Now, if you remember earlier on, we copied the client configuration token down into my home directory. So let's copy it to the appropriate place and restart the service and watch it pick up a license. So let's just hit CP, client configuration token. So I'm just going to copy this file here to, and the correct directory is etc/NVIDIA/client configuration token, client with a capital C. Okay. So that's just copy the token there. Now all we need to do is restart the grid service. Okay. And there we go. So now if we enter the same command again as we did before, so let's just go in here and type NVIDIA SMI-Q, what we'll actually see is that this virtual machine is now in a licensed state. Okay, and expiry here, expiry just means that the token lease expires after 1 day, not the license itself. Okay, so now we've got a running virtual machine. Now, if you want to look to see if you have any errors, what you can do is you can actually go into the file system here and actually have a look in the system logs under var log and syslog. Okay, so let's have a look at the syslog, and information about the licensing transactions or licensing operations will be listed in here. Okay, as you can see right down at the bottom here under NVIDIA Grid D, we've got NLS initialized, so that's when we restarted the service, acquiring license, and it's got the IP address of the server here, and it's put license acquired successfully. Okay, so this is showing us in the log that the license is now working. Now, to be honest, a bit further up, I copied a client configuration token in here that had a host name within it rather than an IP address. So as you can see here, failed to register client, could not resolve server. So I was actually getting some errors earlier on because I put the host name of the license server into the client configuration tokens instead of the IP address, and I haven't set this virtual machine up for resolving host names. So as you can see, you can actually see errors in here, and it can give you some good steers as to what might be going wrong here. Another error that I see in here quite often is to do with time sync. Okay, so if the client configuration token, in the same way as it is with a Windows VM, isn't in sync with the license server itself. So if this VM's time isn't within about 5 minutes either way of the license server's time, then it will fail to acquire a license. So that's another thing to look out for. Now at this point, you probably want to install some other services within here. If you're going to be deploying AI workloads, you might want to do things like install a container toolkit for NVIDIA, or you might want to install Docker or Kubernetes or something like that. Obviously this is outside the remit of this particular video, but we've now got the virtual GPU elements of the solution up and running. Okay, so now you have a fully working virtual GPU system. I hope you enjoyed this video and best of luck with your project.